This is a video from section 16.2. It's in a Calculus 3 class, and section 16.2 is on line integrals. The directions say to evaluate the line integral over c of f dot dr, where c is given by the vector function r of t. On problem 21, we have f of xy is equal to xy squared I minus x squared j. And I'm going to write this, if we don't mind, as the vector xy squared for the first component, and then negative x squared for the second component. And r of t is t cubed I plus t squared j. And I'm going to write this as t cubed t squared. And by the way, t is less than or equal to 1 and greater than or equal to 0. Okay, the first step is I'm going to write f, I'm going to express f in terms of t. So it's a little informal how I'm notating this, but it's going to help us in the end set up this line integral right here. Okay? Now, f is going to be the following. So wherever I see an x, I'm going to replace it with t cubed. So I'm going to put t cubed here. Wherever I see a y, I'm going to stuff in t squared. And that's how I'm going to express f in terms of t. So I'm going to write t cubed times t squared squared. That's the first component. The second component is negative of, now x is t cubed. So I'm going to replace x with t cubed and then square it. Now if I simplify a little bit, t squared to the second is t to the fourth. T to the fourth times t cubed is t to the seventh. That's the first component. And negative t to the sixth is the second component. So that's expressing f in terms of t. Second step. I need to take the derivative of the vector valued function with respect to t. And what that entails is taking the derivative of each of the components. So the derivative of t cubed is 3t squared. The derivative of t squared is 2t. Now, that's step 2. Step 3, I want to take f and dot it with dr dt. So here, now let's write down f. So right now we're just going to do a dot product, you guys. Now f is t, over here, t to the 7th, negative t to the 6th. T to the 7th, negative t to the 6th. And I'm going to dot that with 3t squared, 2t. And so this is 3t to the 9th minus 2t to the 7th. And the fourth and final step is essentially I'm going to integrate f dot dr dt from 0 to 1, and I'm integrating with respect to t. So the integral over c of f dot dr is the integral from 0 to 1 of 3t to the 9th minus 2t to the 7th dt. And it's a pretty straightforward integral, actually. And so here you get 3/10 t to the 10th minus 1/4 t to the 8th from 0 to 1. And when I go forward, I just get 3/10 minus 1/4. And the LCD is 20, right? Sorry, I'm old school. And so this is 6 over 20 minus 5 over 20, I believe, right? And so the answer here is 1/20. And that's how you do problem 21. Let's take a look at problem 22. Suppose f of x, y, z is equal to x plus y squared, that quantity times I, plus xzj plus y plus z k. All right. Now, R of t is equal to the following. We get t squared I plus t to the third j minus 2tk. And this is where t is less than or equal to 2 and greater than or equal to 0. Okay, now we're going to write f. Okay, so step 1, we're going to express f in terms of t. But I'm going to put it in a different form. So here f is equal to the following. Now, the first component, I'm going to replace x with t squared. So I'm going to write t squared here. Y is t to the third. Notice it's all substitution all the time. Okay? So that's the first component. The second component, I'm going to get x, which is t squared, times z, which is negative 2t. And then the third component will be t to the third, that's y, minus 2t, that's z. Okay, and if I go a little bit further, I get t squared plus t to the 6, negative 2t to the third, and t cubed minus 2t. So we're doing the hard work essentially up front. So if I look at the second step here, I need dr dt. Well, essentially, I'm just going to take the derivative of each of the components. So I get 2t, 3t squared, negative 2. Just like this. Third step. I'm going to take f and I'm going to dot it with dr dt. So when I do that, I get the following. I get t squared plus t to the 6. That's the first component. The second component is negative 2t cubed. The third component is t cubed minus 2t. Now, I'm going to dot this with dr dt. So dr dt is 2t, 3t squared, negative 2. So this is 2t times t squared plus t to the 6. So I'm multiplying the first components. I'm going to take 3t squared and I'm going to multiply that by negative 2t cubed minus 2 times t to the third minus 2t. And so this is 2t cubed plus 2t to the 7th minus 6t to the 5th minus 2t to the 3rd plus 4t. And so these 2t cubed terms cancel, and I get 2t to the 7th minus 6t to the 5th plus 4t. Now I'm ready. So after all that work, I can now do my integral. So I get the integral over c of f dot dr. And so that's the integral from 0 to 2 of 2t to the 7th minus 6t to the 5th plus 4t dt. And so this is equal to 1/4 t to the 8th minus t to the 6th plus 2t squared. And we're going to evaluate from 0 to 2. So if I plug that in, I get 1/4 times 2 to the 8th minus 2 to the 6th plus 2 times 2 to the 2nd. Now I already know that 2 times 2 to the 2nd is equal to 8, right? So I'm going to put an 8 here. But I want to show you something kind of neat. I already know that 4 is 2 squared. And so 2 to the 8th times 1 over 2 squared is just 2 to the 6th, right? And so it doesn't look like it, but this term and this term end up being the same term. And so these guys cancel, and you're just left with 8. And so the answer to this question is 8. And that's how you do 22. If we take a look at 23, suppose we had the following. F of xyz equals sine of x times I plus cosine of y times j plus xz times k. And r of t is equal to the following. You get t to the 3rd times I minus t squared times j plus tk. Remember, I, j, and k are the unit vectors, right? I is 1, 0, 0, j is 0, 1, 0, k is 0, 0, 1. And t is between 0 and 1, in fact. Okay? Now, first, again, remember, we're going to express f in terms of t. So now, replace x with t cubed. So we get sine of t cubed. Cosine of, replace y with negative t squared. So we get cosine of negative t squared. And then x is t cubed. Z is equal to t. Again, it's all substitution all the time. All right? And so we get sine of t cubed, cosine of t squared, t to the 4th. Second step, we're going to take dr dt. And again, I'm going to express this in component form. So we get 3t squared, negative 2t, 1. And it's a pretty good problem, okay? Now, look, if I take f dotted with dr dt, I get the following. I get 3t squared sine of t cubed. That's the first term. Second term is minus 2t cosine of t squared. plus t to the fourth. And it works out perfectly because now for the fourth step, I'm going to take the integral over c of f dot dr. So this is the integral from 0 up until 1. That's the restriction on t. And I'm going to integrate what I found in step 3. So I get 3t squared sine of t cubed minus 2t cosine of t squared plus t to the fourth dt. And so this is negative cosine of t cubed, right? It's a pretty straightforward substitution. If you keep in mind, if I were to have let u equal t cubed, my du is perfect. It's 3t squared dt. And so really, I'm just thinking of that as integrating sine of u du, which is just negative cosine u, where u is t cubed. I hope that made sense. Because essentially, I'm going to integrate cosine of, you can call it v. But the integral of cosine of v is sine of v, where v is t squared, right? Because I'm letting v be t squared, dv is 2t dt, okay? So this ends up being plus, that ends up being minus sine of t squared plus 1/5 t to the fifth from 0 up to 1. Plug in 1, you get negative cosine of 1 minus sine of 1 plus 1/5. Plug in 0, can we agree cosine of 0 is 1? So I get negative 1. Sine of 0 is 0, and then 1/5 times 0 to the fifth is 0. So you just get minus a negative 1. And so my final answer here is going to be 6 over 5 minus cosine of 1 minus sine of 1. And that'll do it for this video for section 16.2. I worked problems 21, 22, and 23 in a Stewart calculus textbook, 9th edition. Okay, and so this would be in a calculus 3 class. Thank you.